Okay, in this lesson we'll look at a little bit of something called probability and odds. Let's talk about what does it mean to have the odds in favor. So the ratio of the probability that an event will occur to the probability that it will not occur. In other words, the number of favorable outcomes compared to unfavorable outcomes. Okay, odds against is the other way around. So look at this first example. Bailey holds all the hearts. Okay, there are 13 hearts in a deck from a standard 52 playing cards. He asks Morgan to choose a single card without looking. Okay, I'm going to assume that we're choosing from Bailey's cards, not these 52. Determine the odds in favor of Morgan choosing a face card. Okay, well, how many face cards are there in the hearts? There's the king, the queen, and the jack. So the number of favorable outcomes compared to the number of unfavorable outcomes. Well, that would be 10. Okay, so of the 13 cards, 3 are favorable, 10 are unfavorable. This is the odds in favor of Morgan choosing, 3 to 10. Okay? Let's try another one. Research shows that the probability of an expectant mother selected at random of having twins is 1 in 32. What are the odds in favor of having twins? Well, there's one possibility that they would have it, and then 31 that they would not. That's the odds in favor. What are the odds against? 31 to 1, exactly the opposite. Okay? So this one I want you to try before I do it. So take a minute to read it and see if you can figure it out. Okay, in this case, a computer randomly selects a university student's name to award a $100 gift certificate for the bookstore. The odds against the selected student being a male are 57 to 43. This is the odds against being male. So this must be female compared to male. Okay, determine the probability that the randomly selected university student will be male. Well, remember, what is probability? Probability is favorable over possible. So if the outcome we want is male, how many of these are favorable outcomes? 43. And how many are there in total? There are 100. Okay, so the probability of selecting a male, the probability is 43 out of 100. By the way, we could write that as decimal 43. Remember, the answer had to be between 0 and 1. We could also say this is 43%. Okay, those are all okay. Alright, let's try another one. A hockey game is ended in a tie after a 5-minute overtime period, so the winner will be decided by a shootout. The coach must decide whether Ellen or Brittany should go first in the shootout. The coach would prefer to use her best scorer first, so she will base her decision on the player's shootout records. Okay, so who has a better chance of scoring here? Let's look at the probability that Ellen scores. Okay, the probability of a score here. Okay, it's 8 out of 21. Do you see where I got 21 from? 21 is 8 plus 13. Okay, so let's try the second one. The probability that Brittany will score is 10 out of 27. Now the question is, which one of those is a better probability? Well, this is a good place to change these to decimals. Okay, so we'll get your calculator out. Go 8 divided by 21. And this is decimal 38095. And if I go 10 divided by 27, I get 0.3703. 7. So, who should go first? Who's got a better chance of scoring? The coach would prefer to use the best scorer first. Who's got the more likely chance of scoring, the better probability of scoring? It should be Ellen, because that's the better chance of scoring. Okay, try this one. All right, now that you've tried it, a group of grade 12 students are holding a charity carnival to support a local animal shelter. The students have created a dice game that they call BIM and a card game that they call Zap. The odds against winning BIM are 5 to 2. Okay, against winning. So what are the odds for winning? Okay, that would be 2 to 5. If I change this to the probability of winning, this is 2 out of 7. Okay, let's look at Zap. It says the odds of against winning are 7 to 3. So the odds of winning are 3 out of 7. So the probability of winning is 3 out of 10. Okay, remember the bottom is always the total number of outcomes or possibilities. So 3 plus 7 is 10. So this is a 0.3 chance. And what's 2 divided by 7? That's a 0.286 chance. So which is the game that Madison should play? Madison should play the game she has a better chance of winning. She should play Zap, since the chances of winning are better or are higher. All right. So a couple of key ideas that we've learned so far. You might want to go through those. There's some, formulas like this you probably don't know. You probably don't need to know. That's probably more common sense. You can see that. I would like you to try the worksheet on odds. Okay, that's the next page. And you can also do page 310, numbers 1 to 16.